So what is the empirical formula? The empirical formula is the simplest ratio of atoms present in a compound. So if we were to simplify the number of atoms for carbon, hydrogen, and oxygen, it would give us the empirical formula. Okay, so this right here is currently its molecular formula. So for us to get the empirical formula, we would just have to simplify this. So how do we simplify C6H12O6? Correct. CH2O. Good. What about N2O4? NO2. That's it. And what about water? It's already simplified. What about H2O2 peroxide? HO. All right, that's it. Those are our empirical formulas. The question asks, the molecular mass of a compound containing 49.2% of P and 50.8% of O is 126. What is the empirical and the molecular formula? So let's start with the empirical formula. First step is we are going to be replacing these percentages with grams. Okay, so let's do that. First step, good. Next step is we have to find the moles. And to find the moles, we have to, remember the triangle? Yes, you have to say the mass divided by the RMM. Yep, that's your first step. The next step is we have to, what's our next step? All right, so there you go. All right, so I'm going to take the 49.2 here. All right, that is my mass. And I'm going to be dividing that by my relative molecular mass. And how do I find the relative molecular mass? I just look at the periodic table and find the overall mass for P, which is 30. Okay, 49.2 divided by 30 gives me 1.5871 moles. Oxygen, I did the same thing. The mass of oxygen divided by the RMM, which is 16, and that gives me 3.175. Okay. The next thing we're going to do is we're going to find the simplest ratio of 1.5871 and 3.1715. Okay, how do we do that? All you have to do is divide by the smaller number. Alright, divide by the smaller number. So 15871 goes into itself once, and 3.175 divided by 1.5871 gives us 2. Okay, so we find the simplest ratio. Okay, we simplify these two numbers. That's all that we did. Okay, so there we have our empirical formula. Our empirical formula is 1P and 2 oxygen, which gives us P, 1P, so P1, and then O2, because it's 2 oxygen. That's our empirical formula. So next we are going to go ahead and find the molecular formula. We already know the empirical formula, which is PO2 now. Let's find the molecular formula. First thing you have to do is you have to find the RMM of the empirical formula. Okay, so alright, so that's PO2. The mass of P, of course, we're using the periodic table, people, 31 grams. Alright, and it's only one atom of P, so multiply by 1, and oxygen is, the mass of oxygen is 16, multiplied by 2, it's 2 atoms of oxygen. Okay, and then you know that you're going to add up those two numbers. You're gonna add up the two products, and that's going to give you your RMM. Okay, so you have 31 plus 32 gives us 63 grams, and that's our RMM. That's our first step. The next step is we're going to be dividing the gram, all right, the mass that they gave us for the compound, okay, the overall mass that they give us for the compound, which is this 126 here. This is what we call the gram, okay. So they can either call it the molecular, they could say relative molecular mass, okay. They can call it the molecular mass, or they could tell you it's the ram, okay. So we're going to take that number, we're going to divide it by the RMM. So our ram is 126. So I'm going to put 126 here, divided by the 63 here. for my RMM, and that's going to give me 2. My next step is I'm going to be multiplying my answer in step 2 by the empirical formula. That's it. So this 2 is going to be multiplied by this right here. So I have PO2 multiplied by 2 gives me P2, alright? And then 2 times 2 gives me 4. So P2O4 is my molecular formula. That's it.
Here's a little song I wrote about a type of atom called an isotope. Same protons, different neutrons. Each element on the periodic table has some protons, and that's always stable. Same protons, different neutrons. With an isotope, the thing you'll notice is how the mass number is shrunk or bloated. Same protons, different neutrons. So if you're looking at 2 isotopes, the ANs match, the MNs won't. Same protons, different neutrons. Same protons, different neutrons.
What are isotopes? So isotopes are atoms of the same element which contains the same number of protons and electrons but different number of neutrons. When you hear iso, think about something being the same and something being different. Okay? Think about a triangle. Alright? In a triangle, you have 2 sides are the same. In an isosceles triangle, 2 sides are the same and 1 side is different. Okay, so whenever you hear iso, think something is the same, something else is different. So if we look here, our atomic masses are different, yes, and then our atomic numbers are the same. What does this mean for us? Okay, this means that the number of protons, okay, is going to be 6 because we find the number of protons by looking at the atomic number. The number of neutrons, we find the number of neutrons by the difference in the atomic mass and the atomic number. So my neutron here is 6. My neutron here is 7. 13 minus 6 is 7. And then 14 minus 6 is 8. Okay, that is my number of neutrons. My number of electrons, of course, is equal to the number of protons. It's also going to be 6. So this is why we say that in isotopes, okay, the protons and the number of electrons are the same, whereas the number of neutrons is different. This is because the atomic masses are different. So we are going to be calculating the RAM of chlorine. I know you always wondered, and RAM of course is the relative atomic mass. I know you always wondered, why is it that the mass of chlorine is 35.5 instead of 35 or 36? Okay, this is because it exists as an isotope. Okay, so now we're going to calculate the relative atomic mass for chlorine. Okay, so how are we going to be doing that? So what we're going to do is we are going to go ahead and they give us this information. They have to give you the ratio. They have to. You have to know what ratio they exist in. Okay? So this ratio here, the first number is for the first isotope and the second one is for the last isotope. So the first thing that we're going to do is we're going to multiply the mass of chlorine by its respective ratio, which is 3. Okay, and then we're going to add that with the mass of the second chlorine with its respective ratio. And then what we're going to do afterwards is we're going to divide by the sum of the ratio. And here we have 3 plus 1 is 4, so I'm going to be dividing by 4. Put this in your calculator and you should be getting a number. Okay, so go ahead and try it for me. Put it in your calculator and you should be getting 35.5. And the way that you know that your answer is correct is you look at the periodic table and you look and see what is the mass of chlorine. If you're getting the same, if your calculation is giving you the same numbers which you're seeing in a periodic table, then your answer is correct. Okay. So now we're going to go ahead and we are going to calculate the RAM again, but this time they give us percentages instead of the ratios. Okay, so we have a formula for that. The same formula that you would have used for the ratio, you're going to use again. Only thing is, instead of multiplying the mass by the ratio, we're going to multiply the mass by the percentage. So this is our first chlorine atom, and this is its percentage. So we're going to say 75 multiplied, 75, which is the percentage, multiplied by the mass of chlorine, which is 35, and then added with the percentage of the second chlorine multiplied by its mass, which is 37. Okay, and then you're going to divide by the total percentage, and percentage is always out of 100, so you divide by 100. Okay, divide by 100 and tell me what you get. You should be getting 35.5. Sometimes they ask us to calculate percentage composition. Okay, what does this mean? This just means that, listen, sometimes they want you to tell them what percentage of magnesium is in magnesium carbonate, what percentage of carbon is in magnesium carbonate, or what percentage of oxygen is in magnesium carbonate. That's what they normally ask you. So first thing is we need to get the mass. We need to find out what is the formula mass, the molar mass, relative molecular mass. All of those you might have, but they're asking you for the same thing. Out of all of the masses, magnesium, carbon, and oxygen. Mass of magnesium is 24 because the mass of magnesium is 24. Only one atom of magnesium, so 24 times 1 gives you 24. The mass of carbon is 12, and there's only one atom, so 12 times 1. And then the mass of oxygen is 16, but there are 3 atoms of oxygen, so we have to multiply that by 3. Then you add up all of these numbers, and you should get 84.32. So first thing we're going to do is we're going to find out how much magnesium is in magnesium carbonate. So magnesium, for you to find that, you need to put the mass of magnesium, which is 24, divide that by the total mass of this compound, and then multiply by 100. And that should give us 28.83. So what if we wanted to find the mass of carbon? Again, we would put the mass of carbon over the mass of the total, right, which is 84.32 multiplied by 100. See? And that's given us 14.24. What if we wanted to know how much oxygen was present? Same thing again, the mass of oxygen, which is 48 over 84.32 times 100. That's it.